In this lesson group, we focus in on wind and how it's affected by temperature, and we start learning how to forecast the weather. We'll be using this image of a path ending at a beach with two cyclists to help illustrate a phenomenon, that the cyclists on a beach bike path, they travel faster in one direction compared to another. By the end of this sequence of lessons, students are going to be able to explain this from start to finish, so let's go ahead and take a look. We know that the sun shines down and warms up the ground, and the ground then warms up the air above it. Let's zoom in on a little packet of air at the molecular level and see what it looks like. As a gas, there's space between the individual molecules. When the air starts off cold, there's not a lot of space. But as things heat up, the molecules start moving faster and faster and push each other further apart so that there's more space between the molecules. So if we compare the cold versus the hot, you can see that there are more molecules within a certain amount of space in the cold air than there are in the hot air. So if you actually put them on a scale and look to see which one was pushing down harder, the cold air has more weight, more molecules crashing in to the bottom, pushing down on it. So then we can go ahead and label these high pressure and low pressure. What happens when you have a whole bunch of molecules that are close together crashing into each other, they're going to try and spread out. And where are they going to spread out? To where there's more empty space. So if we take away the containers, the air molecules end up moving in what we call wind. The pressure equalizes when the number of molecules in each area is about the same. So if we zoom back out and look at our original beach situation where we have the air above the water and the air above the land, well, the sunshine is going to shine down just like we said it would originally, but it's going to affect the air and the water differently. The land is going to heat up more quickly, and we end up with higher pressure where things are cooler and lower pressure where the molecules are more spread out. To equalize this differential, the air molecules are going to move, causing the wind from the high pressure to the low pressure. And it's that wind that's going to push against the cyclists so that they can travel faster in one direction than the other. It's really exciting that our students have now developed a model of the cause and effect relationship here. And we notice that the cause is microscopic, but it has a big, visible macroscopic effect. This is really a new level of abstraction for middle school, where we have a microscopic cause, but a visible macroscopic effect, which is really the essence of the scale part of the scale, proportion, and quantity cross-cutting concept. And we can even take this to another scale. The same process is driving the movement of air masses at the scale of continents. Let's see how this looks for students over the next few lessons. In lesson 3.6, we introduce this phenomenon of the two bike riders on the beach. What are the possible causes of this difference? Then students view the weekly weather chart near the beach visual, and they summarize the data and look for patterns. The teacher then introduces a physical model of the beach with containers of water and sand next to each other and does a short demo. We'll use an incense stick so that the smoke will show us which direction the wind is blowing. What do you predict? It's a little subtle, but it's always blowing in one direction. We then challenge the students to think about what sort of questions they have about what happened and how it relates to the original question about the beach. Their goal is to generate one research question and then propose a way to answer it using the materials in the physical model that the teacher just demoed. In lesson 3.7, students discuss yesterday's unequal heating demo, and then they get back in the same groups as the previous lesson so they can finish producing their research question and their procedure to answer it using the model materials. Each team shares out while the teacher compiles a list of the class's ideas. The teacher then implements one or two of those ideas, and each time, students record their predictions of what they think will happen and what actually does happen. Once all the demos are complete, students are going to re-examine their original drawing when they saw just the simple teacher demo, and they're going to modify it to see if they can explain all the things that are going on. In lesson 3.8, students participate in a discussion about how they modified things and what they saw in yesterday's demos. The goal is for students to see a relationship between temperature and the wind direction. Then students are going to participate in the pressure and wind presentation, which introduces the idea of atmospheric pressure and the generation of wind through differences in pressure. Students then revisit the Weather and Climate Unit roadmap and focus on the H's and the L's on the map, making predictions about air movement in these areas. Finally, students revisit the phenomenon, the cyclist moving faster in one direction on the beach path than the other. And then they create a drawing that explains the biker's experience with labels of wind, pressure, and temperature. Students were able to explain what causes the winds, but can they predict them now? In lesson 3.9, we inform students that they're going to need to forecast the weather in their 3 adopted cities by the end of today. They brainstorm what they know about forecasting, and they watch 2 videos about the lighter side of weather forecasting. A short presentation then introduces students to weather forecasting and provides some tips about how to give a good forecast. Then students go and update their weather data for their adopted cities and make a forecast. At the end of the class, they share their strategies that they use to make that forecast. And before they leave, remind them that they're going to have a short quiz next class period on the way atmospheric pressure drives the wind. That's it for this section of lessons. Up next, we're going to improve our weather forecasting techniques.